Docker makes deploying applications incredibly easy, but convenience often hides serious security risks. A misconfigured container can expose secrets, allow privilege escalation, or even give attackers access to the host system. In this video, we'll go through a practical Docker security checklist you should follow before running containers in production. One of the most common mistakes is running containers as root. By default, many Docker images run with root privileges. If an attacker breaks out of the container, they may gain powerful access to the host. Instead, always run containers with a non-root user. For example, use user_add to create a dedicated app user. Running containers with least privilege significantly reduces potential damage. Next, use minimal base images. The larger the image, the bigger the attack surface. Many developers start with large base images like Ubuntu or full development environments. Instead, use minimal images like Alpine, Distroless, or slim runtime images. Smaller images reduce vulnerabilities and make patching easier. Before deploying any container, scan it for vulnerabilities. Containers often include outdated libraries or insecure dependencies. Tools you can use include Docker Scout, Trivy, Snyk, and Clair. For example, running a Trivy scan. Security scanning should be part of your CI/CD pipeline. A very dangerous mistake is embedding secrets directly inside Docker images. Examples include API keys, database passwords, or private tokens. If secrets are inside the image, anyone who pulls the image can extract them. Instead, use environment variables, secret managers, or native Docker and Kubernetes secrets. Secrets should always be injected at runtime, not stored in images. Containers run with several Linux capabilities by default, but most applications don't need all of them. You can reduce privileges using the cap drop all flag, then only allow what is truly required. This prevents containers from performing sensitive operations on the host. A container without resource limits can consume all CPU or memory on the host. This can cause service outages or denial of service situations. Always define limits like memory and CPU caps. Resource limits protect your infrastructure from runaway containers. Most containers don't need to modify their own file system. Running with a read-only file system prevents attackers from writing malicious files inside the container. The simple read-only setting dramatically reduces attack possibilities. Never expose container ports unnecessarily. Avoid binding to all interfaces like point P8080. Consider limiting exposure. Use reverse proxies, API gateways, or private networks whenever possible. Docker images can quickly become outdated. Old images may contain vulnerable libraries. Regularly rebuild images and pull updated base images. Automated rebuilds help keep your environment secure. Docker security isn't about one setting. It's about a combination of best practices. Run containers as non-root, use minimal images, scan for vulnerabilities, and protect your secrets. Restrict capabilities, set resource limits, and minimize network exposure to significantly reduce risk. Containers are powerful, but only when deployed securely. Secure your production systems today.